Okay, so focusing up here, new learning, Newton's laws of motion, and we're going to be real scientific and particular about how we do these. So Newton came up with 3 laws to explain all motion, and in particular they're talking about how forces cause acceleration. Do we know, who knows one of Newton's laws kind of off by heart or thinks they do? Who wants to have a crack at one? Go. Second one? Cool. Newton's second law is F net equals ma. What does that mean? Kieran, can you explain that to us?
Force is equal to the mass times the acceleration.
Yeah. You've skimmed over this word here.
That's not in the...
Is it the net?
Yeah, what does net mean?
Not gross.
What does gross mean?
Gross is like everything.
And what's net? Same meaning. Total, but it means total. It means, if you're accounting for this one force pushing one way and another force pushing another way, they're going to cancel each other a bit. And so it's just the bit that's left over. So net force is like the total accounting for cancellation. When we're thinking about a force, what are we thinking about in our heads? What's happening? Not moving. What's a force? You can have a force without having it moving. Push. Good. Exactly. A force is a push. So when you use that word force, you're thinking push. What's M mean? Mass. What's mass mean?
Kilograms.
Mass is measured in kilograms. What does it mean? What do we mean when we say mass?
The weight.
Not the weight. That's different. Sorry. How much there is? How much, a nice definition is how much stuff there is. Amount of stuff. Matter. How much, actually no one really quite knows what mass is. We don't know why stuff has mass. We know that a bus has got more mass than a car because there's more stuff to it, but what gives the bus stuff? Why does stuff have this mass thing? We don't know. Why? Another way of thinking about it is mass means how hard it is to accelerate something. So if something has lots of mass, it's really hard to accelerate. If you try pushing a bus, it's hard, right? It's got lots of mass, it's hard to accelerate. A means acceleration measured in ms minus 2. So that's Newton's second law. Talks about how if we have a force, something changes its speed. Who's got either number 1 or number 3 for us?
Oh, number 1.
Go, number 1.
Object won't move in motion unless an external force is acted upon it.
Nice. Okay, so in science we say a body in motion will stay in motion at constant speed so long as no net force acts. So if you roll a ball along the ground, if it's really smooth, flat ground, it's going to keep on rolling and rolling and rolling forever. The thing that stops it rolling is friction. If you've got really smooth ground, it's never going to stop. Like ice hockey, the puck slides across the ice, with almost no friction, keeps going forever. If you're out in space and you unclip from your space station, you're going to float off through space. You're never going to stop, you're never going to come back. And at rest counts as constant speed. So if you want to make something move, you have to push it, right? Cool, makes sense. So an object in motion stays at motion.
So if it's travelling at a constant speed,
Yeah.
it's travelling, does that mean the net force has to be bigger than what to change the action?
If it's travelling, there doesn't have to be a force. So once it's moving, something will keep moving forever.
No, but I mean to change the, you know what I'm saying? To change,
To make it move.
to make it not from, let's say this object's moving, right?
Yeah.
And something stops it.
Yeah.
Does that net force need to be bigger? Does friction?
It doesn't need to be bigger, it just needs to be in the if it's stopping it, it has to be in the opposite direction. If something's moving and you want to stop it, you have to push it the other way.
Yeah.
When you catch a ball, you push it the other way from what it's flying. got the third one on lockdown. This is the easiest, it's the one that everyone knows off by heart, but no one quite gets what it means.
Every reaction has an equal and opposite reaction.
And so when Newton said that thing about action and reaction, they didn't have the word force, they hadn't come up with force as a word. So when he said action and he said reaction, he meant forces. He was talking about forces. So for every, what that means, so for every action force, there is an equal and opposite reaction force. Really easy to say, really, really complicated to really get what this means. It means that forces always come in pairs. There are always two forces. You can't push something without that thing pushing you back. And it's complicated because if we think about you and we think about the Earth, what forces are acting? You and the Earth. Gravity. What way does gravity go? Gravity goes down on you, Fg. And what's the pair of gravity? What's the other force? So the pair for gravity, this is where it's really complicated, right? Is that Earth pulls you down because it's got mass and you've got mass. You pull Earth up with an equal and opposite force. Why doesn't Earth move? How come when you jump off a building, why doesn't Earth rise up to meet you at the same rate?
It's very low.
It's got so much more mass. It's got bajillions times more mass than you, so the same force acts on Earth. But if you push Earth with a little force, it doesn't accelerate a lot. So hang on. What stops you from falling then when you are right now sitting on your chair? Why aren't you falling, Reese? Huh?
Is it gravity?
Now gravity's trying to make you fall. If your chair wasn't there, you'd be sitting on the ground quite quickly. What stops you from sitting on the ground? The chair. So what? Talk to me about the force. So the chair is pushing up on you to stop you falling. What force is the pair of that? The chair's pushing on you. What's the other body?
Yep.
You're pushing on the chair. So F of you on chair. You're pushing down on the chair and the chair is pushing up on you. What we're noticing is that forces come in pairs and